Alright, hey kids, this is Mr. Rink here. Sorry I'm not here today, but we're going to have a lesson. We were supposed to have the test today, but wanted to push that back to next week so we can get some feedback for you. So make sure you are taking notes. Remember, your notes are important. If you notice that I'm letting you starting to use your notes in your quizzes and as review days, so or if we have those SPAR review quizzes. So anyways, let's take a moment, let's write this down. And the objective here, everything that's highlighted, please write down. If I could have the teacher please pause the video here and have students write this down. Alright, so today we're going to be solving systems by substitution. The objective here today is I will be able to solve systems of equations by substitution. So you should have been taught this before. But in case you haven't, we're doing a lot of review because we want to make sure you do well on your test this year. But remember, the big idea here is, remember a few days ago I had this lesson where we graphed things on the Desmos, right? Well, let's say we had a graph that looks like this, and then you had another graph that looks like this, right? Where's the answer? Well, the answer is where they cross, which is right here, right? So that's the big idea for today. Now, what do we do if we don't have graph or a graphing calculator or Desmos? Well, we can do this algebraically, and I'm going to show you how to do that. So the big idea still is, where's the solution? It's where the lines cross, okay? These are the steps. If I could please have the teacher pause the video here so that students can write this down. Alright, so these are the steps. If you could, you should have these written down. So, but the big idea is we have two equations. One equation we're going to call y1, and the other one we're going to call y2. If we make them equal to each other, then we can find the solutions. Okay, so here's numbers 1 and 2. There's a little mistake here with the way it formatted. I'm just going to copy this over here. So 3x plus y equals negative 21, okay? And I'll erase the other stuff here. Okay, so number 1. So what do I do here? First thing I want to do, I read the directions always. Solve each system. So I have two equations here that are given to me. Now, each of these equations, I want to isolate the y variable. So this first equation is nice because it's already isolated. You see my y is by itself. So this is my first equation. I'll call this my y1 or y sub 1 equation. The second equation up here is not isolated. You see how y is not isolated? So I could isolate it by subtracting 3x on both sides. And when I do that, I get y is equal to negative 3x minus 21. Okay? Now this y is also isolated, so this could be my y2. Alright? I'll put that in blue so you can see that. So I have two equations now. When you solve a system, you could just set the equations equal to each other, meaning we could take the first equation, y1, and set it equal to the second one. We're saying this whole first one could be equal to this second one, okay? And we could find the solution that way. Because remember, on the graph, when we put them on the same graph, where the lines cross, that's where the answer is, okay? So since I know y1 is equal to this amount here, I'm just going to take 4x and put it here instead. So I'm going to bring it down, and instead of y sub 1, I'm just going to bring down 4x, okay? I'm substituting, okay? Bring down my equal sign. My y sub 2 now, if you notice, it says is equal to negative 3x minus 21. I'm going to bring that over here. And bring it over and write it down. Now I'm going to solve for x. I want to isolate the x term. So I see there's x's on both sides here. So we're just going to use our abilities and skills in solving in algebra. I'm going to put my x's together, adding 3x to both the sides. I get 7x on the left is equal to negative 21. Okay, divide both sides by 7. So x is equal to negative 3. Okay, that's your x value, but remember, I want my final answer to be an ordered pair, like so that it says negative 3 what, right? How do I get the y? Just plug it back in. I'm going to take the first equation, I'll do y sub 1 and rewrite it as 4x, but instead of x I'm going to put in the value of negative 3. 4 times negative 3, and 4 times negative 3 is negative 12. So y is equal to negative 12. So put that in here, and there's your answer. Okay? So the answer to this first one is negative 3, negative 12. Alright? How did I do this again? Oops, sorry. First thing I did is I wanted to isolate the y term on each of these. So you could see right here on the first one, I isolated the y term, and I also called this y sub 1. The second one, I isolated y as well, right here. Set y is equal to each other, and then I substituted what y was equal to on each of these, answering the question what x is equal to, and then also substituting it back in for y. Okay? That's the solution. That's where the lines cross. Alright? And if you didn't believe me, well, I'll show you in a moment. Well, actually, I'll show you now. Sorry, couldn't make up my mind. I was going to show you later, but I want to show you now. But you see how my answer up here is negative 3, negative 12? Check this out on my next slide. Hey, look at that. This answer for number 1, what's the answer I have if I were to graph it? Negative 3, negative 12. Y'all see that? So that's kind of cool. So instead of doing it graphically, we could do it algebraically. I know it takes a little bit more work than going into Desmos, but you do need to know how to do this. Okay? Number 2, I'll do this again. Let me rewrite this so that it's next to it. We got 5x minus y is equal to 2. So just bringing that over here, make some space, okay? So I want to isolate the y, this first equation. I'm going to subtract x on both sides. So I got y is equal to negative x plus 10, okay? And this could be my y sub 1. Second equation, I'm going to subtract 5x on both sides. So we got negative y is equal to negative 5x plus 2. And since this is a negative y, I'm going to have to divide this. It's like saying negative 1. I'm going to divide this side by negative 1 and this side by negative 1. So this side is left with y. Negative 5 divided by negative 1 is positive 5x. Positive 2 divided by negative 1 is negative 2. Okay, and this could be my y sub 2. I'm going to do what I did on the first equation. We got y sub 1 is equal to y sub 2. The two equations. I'm substituting the value in here. I'm bringing this down here. You got negative x plus 10 is equal to, we're going to bring y sub 2 down here, 5x minus 2. Okay, and then we're going to start solving. So I'll bring my x's over. We're going to subtract 5x on both sides. We got on the left side negative x minus 5x is negative 6x. Bring down the 10 is equal to negative 2. Subtract 10 on both sides. You got negative 6x is equal to negative 12. Dividing both sides by negative 6, right, is equal to x is equal to 2. Now that's my x coordinate, right? So if I have my answer, if I put it at the top of my paper as a coordinate or an ordered pair, remember we're trying to find where the lines cross. This one's going to show at 2, right? 2 what? Well, you just plug it into one of the two equations we started with, so I'll just use y sub 2 this time just to show you a different answer. So I'm going to do y sub 2. You see I'm going to bring this all down. Instead of x, I'm going to put in 2. So we got 5 times 2 minus 2. So 5 times 2 is 10. 10 minus 2 is 8. So y sub 2 is equal to 8, right? But that's not the final answer. Our answer is actually going to be where the ordered pair crosses. So it's 2, 8, right? And if you were to do this on your Desmos, which you're not supposed to do on the test, I'm letting you know that now, but if you were to check your work, you can check your work on all your problems today. Just go to Desmos, plug them in, plug the original problem in, and look at this. When I do that, 2, 8, see? So super cool. So I'm trying to connect some concepts together for you. But let me go back here. Let's have the teacher's going to pause in a moment. When the teacher pauses, can we have the students please? It's Thursday, so let's have fours talk about number 1, teaching the rest of the group about number 1. When the fours are done, let's have threes talk about number 2, and then once everyone's done talking, let's write down numbers 1 and 2. Okay, let's pause the video here. Alright kids, you should have written both of these down. So again, check your work. So I know that this was my answer for number 1 and this was my answer for number 2. So on the next page you'll see me graphing these, and you see how my answers match my graph. You see that? So you want to check your work with Desmos, but know that the big idea is, where did the lines cross, right? You do need to know how to do this algebraically. Okay? So that I'm just going to do a couple problems. I want you to work on this with your table. I'm going to give you a set of problems. So right here, let's have the teacher pause the video here, and we're going to have students work all 6 of these out. It's probably going to be about, let's give them about 10 to 15 minutes. If they're done in 10, we could show the answers, but 15 minutes at most, okay? Kids, you should get through this pretty quickly, okay? So let's pause the video here. Alright students, so you should have worked through these, okay? Let's check your work. Remember, you're not copying the answers. I want you to reflect to see how you, if you got these right. And of course, you could have checked your work using Desmos, right? So anyways, here are the answers here. So take a moment to review these. Alright, that's going to conclude the lesson. So you kids have AMs and AM 2.0. Today's the last day to get those done. And other than that, I hope you have a nice weekend. And we'll see you on Monday to create your quiz. Tuesday's a test, okay? Alright kiddos, have a good rest of your day. Bye.